Hello students, welcome to the module number 3, heat treatment, ferrous and non-ferrous alloys. Today we are going to discuss about the following content, that is tempering, austempering and mud tempering. All these concepts we can learn in this lecture video. Okay, let us start with the tempering. So tempering means what? A steel which is subjected to that is a hardening treatment process for the martensite of microstructure, which is going to be brittle in nature. Okay, so even those slight impacts may be caused fracture of the hardened metal. So also severe internal stress, that is what we call residual stress, are going to be set up in the material. So hence what we can do, it is necessary to modify some properties, and it is done by the means of some tempering process. So this tempering process is a heat treatment process that reduces the brittleness of the steel without significantly lowering the its hardness and its strength. So this tempering forms an essential operation that will leads the performed after the hardening. So why we should do this all tempering process? So the purpose of this is, first one is to reduce the brittleness and improve the ductility of the hardness of the steel, and also to improve the toughness of the steel. Okay, and also last one is to relieve the internal stresses. Okay, these are all the purpose, and so how this process is going to be taken place. So initially, this tempering isn't done immediately after the quench hardening. So when this steel cools to about around 40 to 50 degrees centigrade, the process also we can remember of that particular temperature. So it involves that reheating of hardened steel to a tempering below the lower critical temperature. So a line followed by a slow cooling in still air. The reheating permits the partial transformation of martensite. So this martensite is going to be relieving of the internal stresses. So with increasing the tempering temperatures, and transformation of that martensite occurs at faster rate. So based on that, the reheating temperature is going to be decided for some range of temperature may be considered. So those temperature range are, one is low temperature tempering, and medium temperature tempering, and high tempering. So in case of low temperature tempering, what happened? It carried the temperature around from 150 degrees centigrade to 220 or 250 degrees centigrade. So, and also it will be structure still contains a hard martensite, and also internal stresses are will be reduced in this range of temperature, and also toughness and ductility increases without significant of the loss of the hardness. And also it is going to be applied to cutting tools made from carbon steels and low alloy steels, and the case hardening components also they are used. So when come to the medium tempering, it carries the temperature range from 250 degrees centigrade to 450 degrees centigrade, and this hardness and strength of the steel decreases, while ductility or what we call, that is the percentage of elongation, increases. And the results in this fine perlite structure we call it as true style. Okay, true site, so which is less brittle property, and applied to the component such as for coil spring or laminated spring or beams or axles, etc. Okay, even though for the chassis. And third one is a high temperature tempering. So this will be ranging very high temperature, ranging from 450 degrees centigrade to 650 degrees centigrade, and it develops the coarse spherical structure known as the sorbite. Okay, so that will be it develops, and it imparts the high ductility with adequate hardness. So, and it also eliminates the internal stresses completely, and it is applied to a compound such as connecting rods and shafts. Okay, so this and also even for the gears and shafts. So next one is we'll discuss about the Austempering. We'll discuss about the Austempering. This Austempering is a process carried to obtain 100% of granite structure, and which is less ordered than the martensite structures. So you can see in the figure also the process also we can see, so how it is going to be involved. And also it is involving some heating process of a steel specimen to austenite state, that is above upper critical temperature, that is A3 line, so above the A3 line. And it is also followed by a cooling rapidly in salt bath and held it in Bennett range. So usually between the 300 to 425 degrees centigrade it is going to be maintained, and this steel specimen is left in the bath until it austenite covered into austenite and is completely transformed to bainite. So the specimen is then allowed to cool for the air to room temperature, and the final cooling rate of for the bainite structure can be at any rate as no further changes takes place. So the end of this product should be 100% bainite. So here we can see that austenite and martensite will be there at this space, and this will be austenite and martensite on this path, okay, complete path. So this is what we call a surface sampling. This blue color indicates what, that is surface sampling. And this is air cooling. This is bayonet after that at this corner the blue line end up with the air cooling. So this is will be drawn on a temperature time curve graph. And this bayonet structure also have a strength of material and slightly lower the martensite structure, but have a better ductility and impact on toughness. So since this steel does not suffer any severe quenching treatment, okay, it is also less likely what we call crack or dissolve. And however it is as Austempering suffers from a major drawback, okay. And this in Austempering the steel is specimen is caused to go directly into the austenite to bayonet. So this means what, the suction must be cooled fast enough to avoid the formation of perlite. So thin sections can be cooled faster than the bulky sections. So for this reason only the Austempering is going to be limited to a sections less than half of inches of thick. Okay, this thickness can be increased by the use of alloy steels like any alloys additives, tungsten and other materials. Okay, so but time of for completion of transformation to bayonet may be becomes excessive. So this is about the the Austempering. And next we'll discuss about the Mart tempering. Okay, so Mark tempering. So this mark tempering, or what we call mark quenching, is hardening the treatment, and which is permits the transformation of austenite to martensite to take place at same time throughout the structure of the steel. The component with minimum distortion and still stresses. Okay, this mark tempering that is involves a heating of the steel specimen to its austenitic state. So and then quenching in a salt bath and maintained at a temperature above the MS temperature. That is here. Then it is about 200 to 300 degrees centigrade of temperature. It is held at this temperature long through the until the temperature is uniform across the section of the steel component. Okay, so it is then cooled in air and to transfer the austenite to martensite. So in the figure we can observe that this mass tempering we will observe here the surface, okay, and whatever the path we are seeing here that is austenite plus martensite will be there. And this is the transformation, how it is going to be transferred from austenite to martensite. This is about the figure of matte tempering, and this is the path that the bainite and this perlite is going to be converted here. And this dotted line above that, that is a stable austenite. What we are seeing this above the dotted line, that will all it will be a stable austenite. So this is about the matte that is matte tempering. So these all are very important for understanding the property or formation of the different uh, form of that so steels. Okay, so and also some difference will be there that we will discuss in the next class. So there is some difference between Austempering and Mark tempering. I will discuss right now. The steel is quenched to temperature around 300 to 450 degrees centigrade, whereas it is 200 to 300 degrees centigrade. And transformation of austenite is complete in Austempering, and in Mark tempering it is incomplete. And also the process is limited to thin sections in order to achieve the fast cooling rate to transfer austenite directly into Bennett. But here there is no such restrictions at all in mud tempering. So and it consumes more time for the Austempering, and here it consumes comparatively it is less. So this is some major difference between Austempering and mud tempering. So let us discuss some of the topic in the next video.